In this example, we're going to use transformations to sketch the graph of the function g defined by g of x equals -4 times the square root of x. In doing so, we'll identify the original or basic function and then explain how y equals g of x, that graph, is a transformation of our original function. As we do this, we need to make sure that we identify the transformations needed and state them in an appropriate order. When we make our graph, we'll make sure that we show at least 3 key points on the original graph and that we track those 3 points throughout each step. So to start, we will identify that original function. So -4 times the square root of x from our basic functions, the most obvious choice we have for that original function is the square root function. So our original function would be defined then by f of x equals the square root of x. Okay, so here we have -4 times the square root of x, and I have our general form of a transformation written above here, and we can see that the -4 is outside that main function part. So in this case, we're looking at having a equal -4. And so that's going to be, and then b, h, and k are all just their standard values. So b is 1, h would be 0, k would be 0, not resulting in transformations. So all of the transformations are going to come from this value of a. We can look at this. The negative here is going to have an impact, and it will cause a reflection. So a negative outside that main function is going to cause this function to reflect across that x-axis. Or a horizontal axis, in this case the x-axis. And so what we're looking at there is that the output is multiplied by -1. So all of our positive y values will switch to negative, and all of our negative y values will switch to positive. The 4 that we see here is going to, it's outside our main function, so that's going to cause the function to stretch vertically by a factor of 4. Okay, and so as we look at sketching this original function, we need a set of key points to start with. And so if we don't remember exactly what the graph of y equals the square root of x looks like, we can make a quick table. And so I'll do that here. And as I make this table, I want points that are easy to deal with and that I know how to graph. And so I don't want irrational function values. So I'm going to choose x values so that I have integer outputs for this function. And so I'll choose x to be, I'll choose 0 and 1 and 4 and 9. And you'll notice that I picked perfect squares so that when I evaluate for the square root of x, I'll get 0, 1, 2, and 3. And so I'll plot these points. And so I'll have 0, 0, I'll have 1, 1, I'll have 4, 2, and then I'll have the point 9, 3. And then these are going to curve, so I'll draw that smooth curve in there. And that's my original function. Okay, so now that I have the original function, I'll apply these transformations. So the first thing that I'm going to do is reflect across that x-axis. And so, and let me make sure I label that as my first step that I'm going to do. So I'll reflect this across the x-axis. So this point 9, 3 will move to 9, -3. This point 4, 2 will move to 4, -2. This point 1, 1 will move to 1, -1. And then 0, 0 will stay put. And then I'll sketch the rest of that graph in just by connecting those in a smooth curve. Okay, so that's step 1. Now, for my second step, I'm going to stretch vertically by a factor of 4. So what this means is that every y value is going to be multiplied by 4. So 0, 0 is going to stay put. 1, -1, I'm going to now have 1, -4. And 2, -4, now I'm going to have 2, -8. And then 9, -3, that would move to 9, -12. So that's going to move off my graph. So as I sketch the rest of that, I'll keep the rest of that curve, I'll keep that in mind. So I've got these 3 key points still tracked, and so I'll sketch that in, and then I'll make sure that my arrow is pointing out before I get to 9. All right, and that is the second one, and so that's my complete function transformation. So what I have there in blue is then the graph of y equals negative 4 times the square root of x.